Hey, in this video, I will talk about the chain rule and how to use the chain rule to find derivative of composite functions. Okay. First, let me explain you about the chain rule. Suppose we have A, right, and we have B, we have C in here. Let's choose very funny model like this. So A is Troy, B is Montgomery, and C is Atlanta. Let's say we want to go from Troy to Atlanta, but we have to go through Montgomery, right? So suppose I have n possible ways to go from Troy to Montgomery, and then I have m ways from Montgomery to Atlanta. The question is, how many possible ways do we have in order to go from Troy to Atlanta? How many ways? How many possible ways? So that should be from Troy to Atlanta. You have n times m possible ways. Why? For example, if you choose one part from Troy to Montgomery, right, and from here you have n possible ways to go to Atlanta. That means for each part in here you have m ways to this Atlanta. But in this case, you have n possible ways, right? So each time you have n, but you have n times. That means all possible ways from Troy to Atlanta is the product of n and m. So let's say if we look at this model like the rate of change, how to change from Troy to Montgomery and how to change from Montgomery to Atlanta. So we will have a product like product of two rates of change. Okay? And now let's go back to the chain rule. Let's go back to the composite function. So let's say I have this that is Troy, that is Montgomery, and that is Atlanta again. So you see, there's the whole way from Troy to Atlanta, right? The whole way to Troy to Atlanta. And suppose this is F, this is G or F, whatever you want to call, right? And from Montgomery to Atlanta, that is some maps F, some function F. So here we have a composite function, right? F of G of X. So here is X, here is G of X, and this point is F of G of X. And we want to find the derivative of F of G of X. F of G of X. Question is, find the derivative of F of G of X. That means we need to find the rate of change of the whole function, right, from Troy to Atlanta. So based on this example, you can see how to find the rate of change on the whole part. You have to find the rate of change from Troy to Montgomery and find the rate of change from Montgomery to Atlanta, right? And take product. Okay, so what is the rate of change? That is derivative. That means f derivative equal to the derivative of g. That means the rate of change, right, from Troy to Montgomery, multiplied by the rate of change from Montgomery to Atlanta. That is f derivative. But the inside is not x, right? The inside should be g of x because we want to find the rate of change from Montgomery from g of x to Atlanta. That means here we have g of x. And so usually I write f derivative g of x times g derivative of x. That is the chain rule. Or sometimes we say derivative of composite function f g of x is equal to derivative of the outside function evaluated at the inside, right? You see, derivative of the outside evaluated at the inside and then multiplied by derivative of the inside. This is how we can understand the chain rule. Okay, so let me consider some examples and how to apply these rules for composite functions. Okay. Let's set the following one. Y equal to 2x squared plus 1 and 2090. I want to find the derivative of this function. Of course, we can distribute that. We can multiply 2x squared plus 1 2019 times, right? And then you get a polynomial, and then you take the derivative of each term of that polynomial, and then you get your answer. But that's not a wise way to do it. So, let's say if we want to use the chain rule, we have to recognize the inside function and the outside function. So the outside function in this case, power function. Let's say f of g of x. In this case, I write here is 2019, right? And of course, here you have g of x. Make sense? And g of x is 2x squared plus 1. So by the formula of the chain rule, we have to take the derivative of the outside, which is this function, evaluated at the inside, right? And then multiply by the derivative of this guy. So I write the derivative of g of x, the inside function is 4x. And the derivative of this is 2019. We have to bring the power down, and then we reduce the power by 1, right? 2018. And once you have that, you multiply them together, you get the derivative of here I should write f derivative, right? Then I write f g everything in here, derivative 1 to equal to 2019, and then 2x squared plus 1 2018 multiplied by 4x. Okay, that's what we have using the chain rule. Let me rewrite that. How to solve that without these all steps, right? I write y prime. I take the derivative of the outside, which is power function. So I apply the power rule. I bring the power down. I have 2019, and then I write here. I leave this blank. Okay, I don't write anything here. Since this is power function, I reduce the power by 1. I get 2018, right? And then I say this guy, the inside function, we should keep that, right? We should keep 2x squared plus 1. And now I will fill this by 2x squared plus 1. Make sense? Next, since this guy is the inside function, I need to take derivative, right? And then derivative of this guy, I will put in here, I have 4x. Just that. So, the chain rule is not that easy, but it's not difficult, right? Not too difficult. If we could recognize the inside and the outside function, make sense? In case, if you know how to do that, you can write the answer directly. You can use this way. In case if you could not recognize inside and outside function quickly, you can apply it this way. Okay, you write gx, and then you take the derivative of g of x, then you take the derivative of the outside function, evaluate it at the inside, and then you put them back together, right? You multiply them together, you get the answer. Let's consider one more example, and then we finish this video. Let's say the function y is equal to cube root of x squared plus 3x minus 1. Let's say that. So we want to find the derivative of this function. This is cube root. So don't forget about, we can convert any radical function into power function. So since this is cube root, I will rewrite this function in the following form. That is x squared plus 3x minus 1 to 1/3. Right? And now let's apply the chain rule for this function. then the derivative of this is equal to, you see, the power function is the outside one, right? So I have to take the derivative of the power function first. I take the derivative of the power 1/3. I bring 1/3 down, and then I leave it in the blank, right? The power will be reduced by 1. It's 1/3 minus 1. And then I have to copy this part into this. I get x squared plus 3x minus 1. The reason why I didn't want to write this right away, because I want you to keep in mind that many students did wrong. They just write x in here. So I just said, no, don't write anything. Just leave that in blank. Okay? And then you see, you just keep that in blank, and then you fill that blank by the inside function. So you will never get wrong with that. And the next, that is the first term. After this, you multiply by derivative of what? Of this guy, of the guy you just used. Make sense? You just used to fill this blank. So I take the derivative of this guy, I get 2x plus 3. And I'm done. You see? So I hope that this video helps you in this topic, because chain rule is very important one. Most of functions, I would say most of functions are composite functions. Because composite functions are obtained by using elementary functions. So we need to use the chain rule, and we need to know chain rule. And of course, when we study integration, the chain rule will work again. Okay, so like integration by substitution. Okay, thank you for watching, and I hope that you enjoyed the video. If you like that, please subscribe to my channel.